In this episode of Finnugric Machining, we are going to, we are not going to do any machining. We are more like going to do some planning. And what we are planning is this. This is a plastic box which you typically install for your electric installations. So you could put some electric meter in there. This has a door which can be opened like this, and then there is some plastic crap inside and a metal plate. But now what we are going to put into this one this time are the components for rotating. Yeah, that's not needed. Are the components that are needed to rotate the welding positioner. So we will be having some switches, probably here, and stuff inside. But since, I will go with you through the process of my thought when I do planning like this. It's not, so to say, it's not an easy process, and furthermore, so therefore, I will try to enlighten the factors, the facts that impact on these kind of things. There is ergonomy. There are electrical things like capacity, and this I mean how much current they tolerate, what's the voltage they tolerate, etc. And last but not least, safety. So, I will go through each of the components I have here on the bench grinder. It's the so-called flat surface in my shop. I have collected the components that I probably will put here. So, we go through that pile of components and why I chose those and so on. So, let's start with the box itself. So, why this box? This was, the primary thing was that it was cheap. Yes, really. And now, it has, first of all, it's classified in a way that it's splash water proof. So you can throw water in it and it doesn't penetrate inside. So, that's one. Then it and it has this gel type of seal going around here, and it pushes against the rim here. Okay. But the second thing was when I chose this box was that it had a third thing actually was that it's quite empty inside. So there are no excessive forms. It's not like made for certain type of job. Electrical boxes can contain rails and whatever inside them. And then this has one benefit: you can dismantle. Let's see if I can. I haven't tried this yet, but I believe I can pull these hinges off. Yeah, I can. Yeah. So this is, now I have the lid off. And plastic hinges, okay. This is important because now I can put this in my milling machine, because we need to make some very precise holes into this one. Those doesn't need to be so precise, but they look better when they are that way. And yeah, so this is actually quite flat on the top. Let's see if I can get the locking mechanism away from it. That at least there is a screw. Yeah, it looks like it comes off. Yeah, it does. That's the screw. Oh yeah. Huh. Okay. And now it's flat. So I can put it this way on the milling machine, and then I can put holes in exact locations here. Nice. So that's one. And well, yeah, it's a plastic box. What can you tell? So the next thing to go into this box. Well, I start with the component that takes most of the space, and therefore its placing inside the box is really critical. After that you can place the other components. Well, it dictates how this is going to set up, and of course it's this driver, stepper driver. Well, this one I chose because it has the capacity of driving that stepper, and because it has an integrated power supply. Well, the integrated power supply especially caught my attention. So I don't need to put a separate power supply inside there. It's all integrated into this one. And now the intuitive way would be place it like this here in the middle. But unfortunately it's too high. You cannot put it like that there. Instead, I will, after wiggling around with quite a bit, I will put it there, like that. So when you turn this on the correct position, it will be like that. Furthermore, why? This way you can read the labels here, and you can also screw in the terminals while it's in the box. So you don't need to. There is no need to take it out and put it back if you want to screw the terminals. So when I do the wiring, it will be quite easy to do. So that's one component. There will be 3 wires coming out from this box. First of all, the mains wire. The power supply, 220 volts, which you supply power to this unit. And this one you could use an ordinary electric wire with some tension remover and put it under there, and there you are. I don't like the idea because when you stumble into a wire like that, you will cause a lot of damage. But if you have a socket where you put this wire in, then you probably are good. Therefore I will use this kind of thing. Let's see if this focuses. This is, well, it's an ordinary AC adapter, not AC adapter, AC connector, which you find in most computers, which you find in most laptop power supplies. You have probably collected already those power cords in your house like anything else. Seems like these are abundant. So therefore, I put these so you always have a power cord with your device. And of course, this is standard. The power cords are widely available, and furthermore, if you stumble into this one, it will just pull out and nothing bad happens. Yeah. So this will be this, and it will be placed on the bottom of this box. Furthermore, there will be a backing plate inside here because I really don't trust the thickness of this material. I will put an aluminium plate here inside so that it gets proper support from there. That's one. the next wire to come out from this box of these three? It is the motor wire. There is a wire between this motor. This is the wire that's coming out from the box. There will be a shielding on top of this wire because it's going to emit a lot of RFI, radio frequency interference. I don't want that, so therefore there will be shielding. And now how to ensure when the wire is going there and then you have the wires inside. If you pull from the wire, it might do some damage inside here. Well, of course you don't pull, but you never know. So therefore, the next component is quite simple. It's like this. This is a tension remover. You put it somewhere here on the bottom, and then when you thread this wire into this thing, you tighten it, it will squeeze around the wire, and it never comes out until you loosen this nut. That's one. The next wire and the last wire which is coming out from this box is of course the foot pedal wire. There will be a foot pedal which when you slam it down, it will start the thing, and when you lift your leg, it will stop it. Quite simple. And I would like to have a connector with this one. And unfortunately, there isn't too many connectors that are reliable and that are also so that you can just pull them out. The most reliable connectors are locking, so that when you put it there, it will click, lock into there. So, fortunately, this is just, it doesn't carry any strong currents or anything. If you stumble into that one, it will pull the cord out from the connector, and you have to put it back there. Open the connector, of course, and put the wires back, and there you go. So, what I decided to use in this case is, this is coming from musical world. And audio recording equipment usually has this. These are probably the most reliable connectors that I know. This is called XLR. And this is the female part which is put on the box, and this is the plug which you pull into here. This particular female is made by Canon. This particular is made by some Chinese. Anyway, it has gold-plated pins. Same here, everything is gold-plated, the pins. And then you have this nitrile rubber sealing here. And when you push it, you can probably, let me put you near the microphone. You can hear how it really, what this does, it squeezes, the rubber squeezes around the pins, so it will, the connection there inside will be airtight. And it also wipes any excess stuff from the pins when you put them there. And furthermore, when you push them like this, you probably heard the click. Like that, it will stay there. And this one is one of the most reliable connectors that I know of. And these are widely used really in musical world, audio recording equipment. And these are for microphones. You probably know these already, but yeah, and these also are widely available. You can, if you somehow managed to destroy this one, so you can get a new one quite cheap actually. They are not rare. And then this driver had cooling fins and a blower. Fan. This means to my mind that it will somewhat generate heat. And I didn't notice any warming up when I tested it, but nevertheless you have to be aware of this, because they don't put components like this into those devices if there isn't any heat generation. So if you put that thing inside this box, which is quite airtight, it will circulate the air inside there, and it will warm up. It will warm up, even if there is very little heat generation. It will warm it up. So therefore, you need some way of exchanging the air inside the ventilation, so to say. So, you could poke holes everywhere into this one, and that would be really bad. It worked as a ventilation, yes, but it would be really bad idea, because then you have the grinding dust and everything going into the box. And that would not be a very good idea. Instead, I will be using these guys. Let me show you again. These. I will use two of them. They look flimsy, yeah, rather small. But as a matter in fact, you don't need to move the air a lot. Because you don't need to do that. You only need to move it away so that fresh air comes in. And now, the best place what I came with this one is to use these holes here in the backside. So I put these guys here. Let me show you now. Here on the ledge, and then I have a hole inside there, so it doesn't nothing is showing out. So yeah, furthermore, I place these in a way that they will pull the air from inside the box and push it out. And then of course we need some holes for the replacement of the air. These I will put on the opposite side of on the similar place, and after that we have ventilation there. Yeah, okay. So as I said, these look flimsy, but these particular fans are, if they are set up correctly, they are indestructible. The fan blade is floating on magnetic field. This is maglev. The trademark is maglev, and it's these are really reliable. You can run these like 20 years and they still will run as new. The only thing that can first of all, if you poke a screwdriver into them, that will destroy it. And if they collect dust, that's another thing. So therefore I put them so that they pull air inside from the box, from the upper part of the box. And then the air is, they push air out from the box. So, then the replacement air comes from under. So this way, if there are air particles, they stay inside the box, and hopefully it doesn't cause any short circuits there. But yeah, so these are my preferred choice for that one. They are looking flimsy, but they are really good for ventilation purposes. Okay, next step of my path of thought is this lid. All the controls will be placed on this lid, and well, what I have noticed, this is not very, it bends easily, and furthermore it bends this way too, quite easily. So what I need to do here is to put some backing to it. I will use this, this is 5mm thick aluminium plate. That one will be here on the back side, and when I put it there, it will then support the whole thing. It will be much stiffer. This way I can rely on having those components staying put on this thing. Well, yeah, so that's the first thing. I need to put the backing there. So, and now the actual components. I have another picture here, maybe somewhere here, so that you can see, or maybe there, or wherever. I will place it while editing this video. So anyway, this is now. I will try to show out how I place the controls here. So the first control is, of course, always let me show this you again. This is power switch. Yeah, and these are very common in electric appliances. So if this breaks down, it can be easily replaced. You can find replacements quite easily, and they are cheap and reliable. This one is produced by CK, and yeah, and the natural place for the power switch is near the power cord, so that you know, okay, power cord goes there, which is the power, it's quite there. Well, because the power cord, now you can look at the picture, cord is coming about here, this switch will be placed here. Okay. Next component what we will be putting here is the main speed control. I will be using this type of potentiometers for speed control, etc. These are made by ROM, not ROM. ROM. There is a difference of 2 dots in the name. So they will be put there, and these screw into the backing plate. And yeah, this is also a very commonly available component. If one breaks down, you can easily find a replacement for this one. So there will be a thread in the backing plate. It's quite thick, and then I will use, there is a nut which you use to tighten it there. The nut will not be outside the box. There will be only the 6mm hole for the shaft, and but it will be attached to the backing plate, not through. Okay, these are the major controls. I don't want to show, because we have to have knobs for those. So next thing that we are going to have here are the knobs. Well, it's quite easy this time. I have a knob like this, And then I have two knobs like these. So these knobs are really suitable for attaching them onto plastic shaft. They have a taper tightening system which attaches very securely to a plastic shaft. So and it doesn't mark the shaft. That's a nice thing also. So the speed control goes there in the middle. This is a lot lower, so you can easily adjust it like this. So that's the speed control. Then we have two other controls, which are the acceleration speed and braking speed. And these go simply here, like that. And that's my interpretation of you should have enough space everywhere. And then we have these. These are just simple push buttons, like that, and they are Swiss-made, very reliable push buttons, and they will go. Well, I put them upside down here, there and there. So this one is forward, reverse, and start, and these are all push buttons. So it runs only when you keep this button down. When you release it, it will stop. But that's the reason why you have the foot pedal. So there you can then keep it running with your feet. So there is no chance that this thing would be turning without the operator. That's one safety issue. Because after all, there will be quite a lot of torque in this one. It might break something if it is allowed to run freely. So this will now be. This is how I will set up the control panel for this thing. Now that we have all the outside controls here, as you can see, I have removed a few of them. There are two more things that we have to put inside the box. First of all, this controller requires, even though it has an integrated power supply, the controller, the brain box, needs a power supply. Well, I'm going to use this one. It's again, this is 12 volt switching power supply. It will go somewhere inside the box. I will remove this AC connector from there. I will also remove the DC connector. And I don't know how maybe I can package it so that it's, let's see how I do with this one, but I will make it so that it's safe. So this is just providing supply for this brain box. The brain box has room in this corner. That's where I will put it. It will be upside down, attached to the 5mm aluminum plate inside there. Nothing fancy about this, it will be there. And it's evident that when we have it like this, the wiring is really easy to do, because most of the wires are between those control knobs and this brain box. So therefore it's very convenient to have it near the controller, have those two things near each other. Now, this about concludes this episode of Finno-Ugric Machining. And we are, in the next episode, we are going to, we are going to start by putting the things inside the box, like the controller, the fans, and maybe this power supply, and etc. That's the first step, and if that goes fast, we can also make the controls. There will be at least one additional episode, maybe two, for this one. So this is all about planning ahead. Yeah, and in the next episode we start with this one. So, till then,